Okay guys, so this video is about the derivative of inverse functions. People had so much fun with the inverse trig derivatives. They asked, Boris, can we take the derivative of any kind of inverse function? What's the relationship there? And of course the answer to that is yes. What a great question. So before we begin talking about inverse derivatives, I want to remind you what an inverse actually is. If you remember inverse functions from Algebra 2, feel free to skip this video. If you don't, let's just take 2 or 3 minutes and fill it. So we say that f of x and f inverse of x, which we write like that with an f like -1. It's not f to the -1 power. You just write that f -1 to denote that this is an inverse function. So we say these are inverses of each other such that if you have y is the function of x, then x is the inverse function of y. Meaning that if f of 2, say, is equal to -6, then f inverse of -6 is equal to 2. The key idea that you can see here is that when you go from a function to the inverse function, the x value and the y value switch. And that, I think, is something you should always keep in mind whenever you're dealing with inverses, and that'll kind of help guide us when we start thinking about derivatives as well. So what I mean by that is, if we have the point 2, 3, if that is on the graph of f, well, what that means is that then if we switch x and y, then 3, 2 is on the graph of f inverse, the inverse function. So what that means then is if you were to say like graph some points here, like let's say we were to graph some function. So if you start at 0, 2 and you go up to, I don't know, like 3, 5. If this is your graph of, that's a bad example. Let's go up a little higher to 3, 6. Okay, so if you go to 3, 6. If this is your graph of f of x, then if you want to see what the inverse graph looks like, the inverse, again, all we're going to do is we're going to swap x and y. So instead of starting at 0, 2, we're going to start at 2, 0. Instead of ending at 3, 6, we're going to go over to 6, 3, 4, 5, 6. Okay, so there's 6, 3. So that's an example of the inverse graph. If you're curious, by the way, they reflect across the line y equals x. It's just kind of your picture mirrored over that line. Okay, so that's what's going on there. One of the problems which may be useful to us along the way is to find an inverse function. So for example, if I tell you if f of x equals 2x plus 7, and I ask you to find the inverse function, f inverse of x, here's what you do. You write this as y equals 2x plus 7. And then, well, when you get to an inverse, you just switch x and y. So you're going to switch the x value with the y's, any x becomes a y and vice versa, and then you're going to solve for the new y. So you do x equals 2y plus 7, so we solve for the new y, so 2y equals x minus 7, so y equals x minus 7 divided by 2. Okay, and that would be what your inverse function looks like. Great. So that's the basics of inverses. One thing I did want to point out to you, this is kind of an interesting relationship, that f and f inverse kind of cancel when you apply to the same thing. So if you take the function of the inverse function of x, the f and the f inverse cancel and you just get x. If you take the inverse function of x, those cancel and you just get x. We've seen this before, right? If you take e to the natural log power x, you get x. If you take the sine of the inverse sine of, say, I don't know, like 1/2, you get 1/2. That's the inverse relation. They cancel each other out. Okay, so that's what an inverse is. The next video, we'll talk about derivatives.